Namaskaram everyone, welcome back to the 68th episode of Master Unreal series. So right now we are doing the shop system. In the last episode I showed you how your customer can interact with the shop. So in this episode your customer will be able to raise a trade request, which means he can request for an item and the merchant will approach the desk. And for those people who do not know, we are using smart objects and state trees now. So feel free to check out the previous episodes to get the idea of how the shop system is building. Okay, so without wasting any time, let's get started now. All right, so let's start. There's one small correction that we have to do. This set availability function is not returning anything, so we should make it void, okay? So I forgot to do that in the last episode. Great. So let's come back to our old project and make sure you have hit the live coding once that change is done. Now we created the interact with environment state tree and it will take you to the smart object. And once you go to the smart object and you start interacting with it, the customer will get this customer trading state tree injected. So let's define what will happen in the case of customer. Okay, so we want this state tree to serve all NPCs and all different type of shops. So we are not going to change this schema. And now let's see what's the first state. So first of all, when you come here, you are going to request an item. So you will say request item. Second, you will collect the item. Okay, so these are the two things. And once you collect the item, the tree should end. Cool. Let's focus on the request item. So first we will create a trade request which will contain the information of the customer and what is the item he wants and etc. So for this, what we will do, we'll go in tools, new C++ class, and it's an object. So I'll go to all classes and select this object. And I will call this trade request. Okay. And I'm going to create a new folder and I'm going to say smart objects. Okay. And in this one, let me remove the space. So let's create one more folder that says shop. Okay. So this is a smart object and I will open this folder and this is where I want to place my trade request. Okay. Once it is done, you can click on reload all and let's remove the prefix because trade request.h is present in the same directory. Okay. So we will go to trade request.h. Cool. So we will create some variables and they are not private, but they are protected in case you inherit a new kind of trade request. You can do that. So I'll make all my variables protected so that child can access to. And we do not want to give public access to these variables because we don't want any other entity to modify the parameters of trade request. If you want to update the trade request, you have to call the functions. Remember the Swiss bank explanation from gameplay attributes? We are going to follow the same pattern here. Okay, so first of all, the trade request involves the customer. So I will take customer, but what would be the type? We cannot take pointer to the actor because like I told you in the last episode, your player or any environmental incident can kill the customer. So in that situation, you cannot take raw pointers. So what we are going to take, we are going to take weak object pointer to the actor. Okay, so this will be your customer. Second, we want to know the shop. So again, it will be weak object pointer. Why? Because if your game is really big and you are doing level streaming, which you will be doing for sure if you do not want to see lags and high memory and CPU uses, you will use the level streaming and dynamic level loading. So in those situations when the level streaming works, let's say your shop got disappear. In that situation, this will become invalid. So we cannot take raw pointer again for the shop. Then same thing for the merchant, you can kill the merchant. So we are not taking raw pointer either here. Now the last thing, what is it that the user wants or the customer, NPC or player wants is the item. So the item will be from inventory item definition. As you all remember in the last episodes, we have created this. So your inventory V2 system right now has this rifle gun with you. So you will be taking this class name and then you will be accessing the default object. So this rifle definition or all the items that you have in your game are derived from the inventory item definition. All are the child classes of this particular class. So we will say we want the subclass of U inventory item definition. Okay. And we will say requested item class. So this is the item you're looking for, and we will tell Unreal that believe that this class exists. Okay. We are not going to import its header file because we are not accessing anything from inside. Now we will create the getters and setters from the Swiss bank example. Okay. So what I will do, I'll create a public specifier, and this is the place where we will create the getters. So let's go. First of all, you need the customer. So blueprints do not accept weak object pointers. They need the raw pointers. Okay. So you cannot type the return value as t weak object pointer. You have to write a actor pointer. Okay. So how we will convert this weak object pointer to the normal pointer is, let's say you call for get customer, you will return customer dot get. Okay, this is the function which will give you the normal pointer. See, everything is fine now. So like this, you will return all three. So what I can do is just copy 3 times, and I can replace this with get shop, get merchant, and I can copy these variables here. Okay, then the requested item class. So this one is as is. We will say get requested item class, and I'm going to return requested item class here. Now let's continue. We need setters so that we can update their values. So C++ setters. And what I'm going to do is create 4 void functions to set the customer, then set shop, then set merchant, then set requested item class. Okay, so let's do it quick. Again, you do not accept the weak pointers, you accept the normal pointers here, and then you will convert it. So okay, so these are your setters, these are your getters. So if you want to update any detail, you have to call these functions, and you want to get, then you have to use them. Now we will create a static method similar to what you created in the inventory manager with me, the create item instance. Remember, I told you static methods do not need any reference, object reference. So you can call them directly, whether in your blueprints or in your C++. So for example, in the item instance, you were creating the item instance. So we will create a function that will allow you to create a trade request. So we'll say static, and you are going to return a trade request. So you trade request, and the function name is create trade request. Now, whenever you are creating an object like this, I told you you should always get the outer so that you can control the life cycle of the object. So when this trade request is raised, who will own it? Okay, like for example, in case of merchant, it's the James character that holds the merchant component. So if the James character dies, the merchant component dies. So similarly, this trade request object should be destroyed if no one is using it. Okay, so what I'll do, I'll give an option to provide an outer, and I'll say you object pointer outer. And now when you are raising the trade request, what are the important data? What is the essential data that you need? First, you need to know the customer, the shop, merchant, no, because merchant is something that will be assigned by the shop counter component. You cannot assign the merchant. And then we need the request item class. So if a customer is reading the trade request naturally, then they need to provide the customer information, shop, and the requested item. So what I'll say here is that give me the customer. So I'll say input customer. Then we need the shop. So let me copy this, input shop, and then we will say input merchant. So these are the 3 details. If you give it to us, then we will create the trade request for you. So let's implement its logic. Now, like I always said in the last episodes of C++, always check the pointers. So the first thing we have to check is the outer. Let's say if the outer is not provided, let's say no one is ready to own this particular object of trade request, then we will tell Unreal or the C++ system that create this object in runtime memory, which means if no one is using it, then destroy it. See, the idea is to save the memory, to free the memory as soon as possible and whenever possible. Okay, so if no one is using the trade object, then we should not keep it in our memory alive. So what I'm going to say, if the outer is not valid, not, then outer is equals to get transient package. Okay, so this will tell Unreal that this is created in the runtime memory. So as soon as no one is using it, destroy it. And if there is anyone who wants to own it and control its lifecycle, then we will accept it as it is. So we'll say new object, object of what? U trade request, provide us the outer. So here you go. And now we need to store it. So you will say U trade request pointer and you will say trade request object. So you created an empty trade request object. Now you start putting up the details. So it's a pointer. I will use the arrow. So arrow, what do you want to set? The customer. Okay, so we'll say input customer. Then I would like to set the shop. So I'll say input shop. Then I would like to add the merchant. No, sorry, my bad. I will go back and this should not be merchant. Oops. Let's copy the requested item. Go back. Fix this. And then we'll say set requested. And there you go. Okay, so you have initialized the variables that were essential for raising the trade request, and now you are going to return it. All right, cool. So you have a method and you have all the properties for the trade request. Oh, my bad. It should be pointer. So sorry. Okay. Now let's head back to our shop counter. Okay. So when the customer will be injected with customer trading tree, this will be called, the request item will be called. So what the request item will do is call the shop component to raise a trade request. So what we will do, we will create a public function, okay, in the shop counter, and we'll say void request trade. Okay. Now, first of all, you need to give us the customer. So we will say actor pointer and customer. Then you need to tell us the item type that you want to buy. So what I'll do, I'll write class U inventory item definition because we do not want anything from inside. So we will say T subclass of U inventory item definition, and let's say input item. Okay, so if you want to make a trade with the shop, then you have to provide these two information and then this will raise the trade request. So let's create the definition. So first of all, like I always say, check the pointers. So if the customer is not valid or if the item class is not valid, then just return. We are not interested. But if they are valid, then I would like to raise the trade request. So I will include the header file and I'll go one step back because I'm in the components directory. Then I will go in the smart objects. Then I will go in the shop. Then I will import the trade request.h. Okay, this is our path. Great. So let's raise the trade request. So I will request this class to create trade request. So first of all, we have to provide the outer. I'm going to pass it null pointer because what I want Unreal to do is that once this trade request is not part of any execution, then remove it from the memory. Because if I pass the outer, let's say shop counter, then the shop will be valid throughout the game. So this trade object will live. And if I have 100 requests, they all will live. I don't want that. What I want is if there is no one attached with that trade request, then destroy it. The garbage collector will take care of it. So I'm going to pass the null pointer so that the transient package will put that in the runtime memory. Okay. The next thing we want is the customer. So let's pass the customer. Then we want to pass the shop. So get the owner of this component, which is the shop counter component. So this will give me the wooden shop table actor. And then I would like to pass the input item class. So input item class. Now we have to, first of all, let's store it in a variable. I'll say trade request. So now you might be receiving a lot of trade requests, but at a time a merchant can only attend one. So we need to store this trade request meanwhile. So I'll create a private variable that will be an array of trade request pointers. So trade request pointer, and I'll say pending requests. So this is the variable where I will store my requests. So what do we do here? Pending requests dot add this trade request. Okay, and as soon as I add the request, I need to make an attempt to see if there is any merchant who can take it, because I don't want my shop to continuously check if there is any pending request. Okay, so what I want is, if there is a new request that has came into the picture, just make an attempt to assign this to merchant. So I will create another function to do that job. So what I'll do under the private, because this is an internal thing, I'll say void try assign request. So I'll create the definition. So first we are going to check if there is any pending request. So if the pending request's length is equals to 0, then return. We do not want to go ahead because there is nothing to process. But let's say if there is a request to process, then we have to find the merchant who is available to attend, because there is a possibility. Let's say there is a trade going on. So we have to first check if there are any merchants available, and if there is only one merchant, then we cannot help it. We have to wait till the trade is over. So we have to get the available merchant. Again, a separate function for that. And we need the merchant component. We do not need the actor, because all the logic of trade is present in the merchant component. So what I'll do, I'll copy this pointer because that's what we need. And I'll say get available merchant. And we are going to create the definition of it. So what we are going to do, we are going to iterate over the assigned merchants of the shop, merchant entry, that is the type, and reference, so that we do not create a copy. And we put a constant because we are not modifying anything. So just to prevent that. Now first we check if the merchant is alive or not. So entry.merchant is valid. If he is not valid, then continue. But if he is valid, then return the merchant component. But is it correct? No, it's not correct. You just check if the merchant is valid or not. Basically, he's dead or not. But let's say if he is valid, then we have to check if the merchant component is valid. So I'll say entry.merchant component. Is it valid or not? So if it is not valid, then also continue to the next one. But let's say if merchant component is also valid, then in that case, we have to check if he is available, because he might be engaged in a trade, then we cannot proceed. So we'll check entry.merchant component arrow is available. So if he's not available, then also continue. But let's say he's valid, merchant component pointer is valid, and the merchant is available, then we can return this component. Otherwise, we will return null pointer. We did not find any merchant after scanning this entire array. Okay, so we can call him here, and we will say merchant component pointer, and we'll say merchant comp get available merchant. And if merchant component is not valid, then return. We cannot assign a request to an unavailable merchant, right? Now here's a catch. Let's say if customer X is trading, okay? Let's say there's a customer X who is in trading and there are 3 people waiting. But now your player comes in. Now he holds the highest priority here. You are working and making your game for the player, not for the NPCs. So in such situation, your player should hold the highest priority in the queue. And we also want merchant to abort this trade and focus on our player, because we can't keep him waiting. So basically our first thing here is that we want to take the player request. Again, this has to be done in a function because this function just assigns a request, but getting the request is job of another function. So I'll say I want the trade request from the queue and I'll say pop next trade request. That's the function name I would like to give. Okay, let's create the logic. Okay, so first thing we will check if there is any request in the array. So if pending request dot num, which gives us the length, if it is equals to 0, then return null pointer because there is nothing to process. However, if there is something to process, then we would like to take it out. So we will go for u trade request pointer and the request that we are going to take is the first one. Okay, and since we have taken this request in this variable, now we can remove this from the queue. So what we will do, we will say pending request remove at 0. Okay, so the request that was at 0th index, remove it because we have consumed it, and we are going to return this request that we have just extracted. Now for this moment, for this phase, we are just considering our NPCs and AI characters so that they can get the items from the shop. But for player, we will process the requests here. So priority, or like give priority to player request. So you can write that logic here, but we will do that later. For now, let's work it out for the NPCs and AI. So what we are saying, give us the next possible trade request. And I'm going to call this function here. So u trade request pointer request pop next trade request. Okay, if this request is not valid, the pointer, then return, we cannot continue. But if this request is valid, that means the merchant is also there, request is also there. So ask this merchant to begin trade for this particular request that has been assigned. So what we are going to do in the merchant.header file, I am going to create a public function. So let's create a public function and we will say void, or let's say bool start trade. And what is the trade request? This is the one that we are passing. Okay. And we are also going to store this request in a variable. So u trade request active request. So if you want to know what merchant is doing right now, like what request is he processing, then you can check this variable. So I will initialize it with null pointer and we will create a getter and a setter. So u trade request pointer get active request const return active request. And then we will create a set function. So set active request. Okay, so you have created a getter and a setter. Okay, so let's create this logic of start trade. What we will say, assign the active request to this one. So set active request to request. Okay, and we are going to return true that we have started the trade. And let's include the header file of this trade request. We have to go merchant component one step back, and then we have to go in the smart objects shop, and there you will find your trade request header file. Okay, so you got it. There is one more thing. Let's say if the merchant is already doing some trade, then you also want to stop it because you requested to start a trade on this request. So if there is a existing request going on, then you would like to abort it. So what I'll do, I'll go and create another function and I'll say bool abort trade, or let's say current trade. Okay. Why I'm saying bool is because later if you cannot abort certain trade, then you should be able to make that message to the start trade. So what I'll do, I'll create the definition in abort current trade. And first of all, I will ask the merchant itself to abort the current trade. So I'll say abort current trade. Okay. And what this will do, it will set the active request to null pointer because we are no longer processing it. And we'll say return true. So for now, you can abort any trade, but later on, you can make it optional by adding some more checks. Okay, so first we abort the current trade, then we set the new request, and then we start trading on it. Okay, so we are all set here. And there is an error, so let's go to header. Okay, so now you are assigning this request, so you need to include the header file of trade request. So what I'll do, I'll copy the smart object shop trade request here. Okay. Why? Because in the header file, you are writing the logic of assigning the trade request. So when you are assigning, it is checking whether this is of same class. So you need to include the header. Now you cannot get away with the declaration. Okay, so you are all set here. Let's go back to CPP and we will say the merchant component that start this trade that we are passing right now, and it will automatically abort the current trade and it will start this one. Okay, that was the logic. Okay, so if you saw something here, just forget it. I was re-recording this part so that I can explain it better and cover the use cases. So this new request came in. Now first we will put it in the queue. So we will say pending request dot add and add this trade request. Okay, now you assign the request, or I must say make an attempt to assign this request or any other request that is there in the queue so that we can start making it empty. So hit the live coding to compile and the build is done at my end. I will go back to my AI architecture, sorry. And in here you have the customer trading. So let's create the trade request. I will create a task. Okay. And here I will say STT underscore request item to buy. I'll save it here. Now we go back and we will add this task here. So plus and request item to buy. Now let's see. I will trigger the enter state. Now first thing, we would like to get the shop component so that we can request that shop to raise a trade request. So I need a variable. I will say shop and I will say actor because I am expecting an actor here, and I will put that in the context category. Why? Because this is our character or NPC or AI who is interacting with the smart object, and the smart object is this. Okay, so let's bind this property to the smart object, compile, go back. I'll take my shop and I'll get the component by class. So get component by class, and it is the shop counter component. Okay, so first of all, we will check if it is valid or not. So is valid. So if it is valid, then fine. If it is not valid, then finish the task. That means we cannot. So we got the component. Now what we will do, we will request the trade. So we'll say request trade. I'll connect this. So who's the customer? Let's promote it to variable. And again, this is also present in the context. So drag it in the context category, or you can change it from here. And we will bind this in a second. Then we need the item class. For now, I'm just going for rifle definition that we have created in the past episodes. This one, you have all the details. Later, we will create a small subsystem that will generate which item to buy based on the need of NPC. So that is a separate story, but for testing purposes, right now we are keeping this rifle. But later on, it will be replaced with a variable. Great. So you request the trade, but the problem is it is not returning us. So let's go back, and we want the trade request so that we can use it in our state tree. So what I'll do, I'll go to header and I will change this to U trade request. So we are going to return the request that we have created. So let's return it. And we also need to change the return type here. And let's also return the null pointer, because if the trade is not started, then null pointer. And we will also check if the trade request here is valid or not. So if trade request is not valid, return null pointer in that situation as well. Okay. And let's put the checks. I hope you got that exercise message. Now I will do that here. So what I'll say, if input shop, so if it's not valid or your input requested item class is not valid or your customer is not valid, then in these three situations, we would like to return null pointer. That means we were not able to raise the trade request. Okay, so you have all the checks placed. Hit the live coding. Okay, so it compiled and now you can refresh and you will get the trade request object. So what I'll do, I'll promote this to variable and I'm not able to do that. And that is because your trade request is not of blueprint type. So I'll make it blueprint type. Go back, hit the live coding again. And let's delete it. Add this again. So request trade. And now you can see there is this live coding trade request 0 object reference going on. So for this, you have to close the project and just rebuild it again. So if you have already built and in that situation, if you hit it again, then it will clash with the live coding. So, okay. So let's open the editors back. Now you have the valid trade request. Okay. So we'll connect the customer. We'll say rifle definition. So now first I will check if this is valid or not. Okay. And then I will promote it to the variable. So check if it's valid. And if it is valid, then right click, promote to variable, trade request. And let's put it here. Now, if you were not able to raise the trade request, then you have to finish this task with succeeded to false. Okay, great. Okay, so now if everything went well, then we will say it is a success. Cool. Compile, save all, back to customer trading. And so let's bind the customer first. Now here's the thing. Once you request the item, you have to wait. Okay. Once you complete the request, you have to wait till the merchant comes to the counter and place the item in front of you. So till that point, you have to wait. So what I'll do, I'll add another stage, that is wait for request completion. Okay. This is the new state that we are in. So what I'll do, if the state is succeeded, that means the request is raised successfully, then I will say wait for request completion. And if it failed, then the tree failed. Okay. And here, how do we know when the merchant has placed the item in front of us? That's a big question, right? So for that, we have to go to our merchant component. So what I'll do, I'll first of all make this merchant component blueprintable. Okay. So I will say it's a blueprint type and it is blueprintable. Okay. So save. Let's remove this warning. So now my merchant component is blueprintable. Now some of you might be getting really happy. Oh, finally we are in the blueprints. But okay. So I want the state tree logic to be done in the blueprints because right now I do not trust state trees to its fullest. So to keep the errors out, I'm going to make this a blueprint component. So for this, what we are going to do, we are going to go in AI. I'll add a components folder. So components, and I'll move this travel behavior inside this. And here I will create the component from this merchant component. Okay. And I'm going to name it BPC merchant component. Now we are going to add this in the James character. So let's go back to AI characters, James, and I'll delete this merchant. Oh, it crashed. Okay, let's restart all. Okay, so it's back. Let's open the editors. Let's remove the merchant now and add the BPC merchant here. Okay, so I will go in edit. Now this is where you can do the state tree logic. So what we are going to do when a new trade has been started, we would like to be notified here so that we can do some logic. So in the merchant component, I am going to create one more event that will be blueprint implementable. And in past, you have done this with me in the base character. Let me show you. I think it was in, yeah. You see, when the health is changed, you used to fire this event. So we are going to do the same thing, the blueprint implementable event. So what I'll do, I'll go back to header file and I will say void on new trade started. We are going to implement this and we are going to let blueprints implement it. So we'll say blueprint implementable event and under the category, we will say merchant. Okay, and we will call this as soon as a new trade has started. So in the start trade, I will call this on new trade started. And let's also pass the trade request. So I'll pass it here and I'll go back and add this U trade request parameter here so that you can get the trade request in blueprints. So third person map, hit the live coding again. Okay, now you can go to merchant component, event on new trade requested, and you got this request with you. So what we are going to do here, this request contains the shop. So we'll get the shop. Okay, let's check the shop counter.h. Sorry, trade request.h. Okay, we have not exposed them to blueprint. So let's expose these functions. I'll say u function blueprint callable. Okay, and expose all these functions here so that all the entities in your game can read this trade request information via these functions. Let's go back, hit the live coding again. Once it is done, go back to merchant component and you can now get the shop. And I'm going to check if this is valid, because if it is not valid, then there is no point. So if it is valid, then in that case, I would like to say find smart object in this actor. Okay, so let's connect it. And user is this particular owner. So we'll pass the owner here. And now for filter, we will make it. So make smart object request filter. And here you will say, I want the merchant slot. So smart object user dot merchant and rest of the things will be default. And this will give you the results. So if this is a success, then I would like to get the first available slot. So get a reference of it. And I will mark that slot as claimed. So let me break it. And this is the slot. So I will mark slot object as claim because this merchant will be coming here. And so what you can do is plug it here. And then I will start moving towards the slot and use the gameplay interaction. So get owner, get AI controller, pass it here. Okay. Okay, so after hitting the compile, we are getting this error. Let's remove it and go for event on new trade requested. Again, the live coding thing. Damn it. Okay, so I have to rebuild the project. Damn it, this is so annoying. Okay, so usually this is not the way where you keep hitting the live coding. So first you get completed with the C++ and then you start with the blueprint work. That's usually recommended in such situations. So I'll connect them back and we are good now. So I can compile and I will save all. Let's see if the merchant works the way we want him to work. So I'll put this merchant a little far from the slot right here. Okay, so if I play, the customer goes and the merchant comes here. Okay, so merchant is listening to you. All right, so that's it for this episode. I hope you enjoyed it. Do let me know if you have any doubts, queries, suggestions, questions in the YouTube comment section. And the Discord link is always there. You can join and share your problems over there. All the assets that are used in this series are available for free so that you can focus on learning the core process. So in the next episode, we will work on our merchant because right now our merchant is listening to the trade request. But now in the next one, we will see how you are supposed to process, how you're supposed to pick the items and hand it over to the customer. So we will do that in the next episode. So stay tuned. And if you like my work and you want to support me, the Patreon and the coffee link is in the description. Please have a word with me before buying any membership. So I will see you in the next episode. Till then, you take care. Bye bye.